let A be the following matrix: cos x, sin x, minus sin x, cos x. We want to prove that A to the power n is cos nx, sin nx, minus sin nx, cosine nx. Here, for n bigger than 1, okay, n is a natural number, we will prove this result using the principle of mathematical induction. To prove this result, we assume that one knows the cosine of the sum of the angles and the sine of the sum of the angles. These formulas must be known by heart, and also the multiplication of matrices. Okay, let's do the proof in this case. So first we check that this property that we want to prove, which is a to the power n, is true for n equals 1. We see here that if we let n equals 1, in this case, we're going to have the cosine of x, sine x, and minus sine x, cosine x. This means that a to the power n is true for n equals 1. We assume that this property, which is a to the power n, is true for n, and we want to prove that it's true for n plus 1. Okay, so here we have a n plus 1 is a to the power n times a. And we have, by the induction hypothesis, that we know the formula for a to the power n. We know that's cosine nx, sine nx, and minus sine nx, cosine nx. And we know a is cosine x, sine x, minus sine x, cosine x. Okay, now we're going to use the product. Okay, the product of two matrices. Here we're going to multiply this row by this first column. Okay, we get cosine component-wise. The product should be component-wise. Cosine nx times cosine x minus sine nx times sine x. And here in the second column, first row, we have cosine nx sine x plus sine nx cosine x. Okay, now for the second row, first column, we have minus, that we're going to take outside, minus sine nx times cosine x plus cosine nx sine x. And for the element in the second row, second column, we have minus sine nx times sine x plus cosine nx cosine x. Okay, here, using the rules of the sum of angles, we see here that we have, this is cosine n plus 1x. This is cosine n plus 1x. And this one here is just the sine n plus 1x. And here, with the minus here, we're going to have the sine of n plus 1x. And here, we're going to have the cosine of n plus 1x. Okay? Therefore, this is true. This is n plus 1. So here, instead of n, we have n plus 1. And this is a to the power n plus 1. That means when we switch n by n plus 1, we get this result here, which is true. Okay, therefore, okay, our expression or our formula for a to the power n is true for all n by the principle of mathematical induction. Okay, this means that this is true. Later we're gonna give some geometrical explanation for the meaning of these powers here. Remember this matrix, we will have to use it later.